The mysterious leaps in evolutionary history, such as the Cambrian Explosion and the rise of flowering plants, remain enigmatic due to their suddenness and the complexity of the changes involved, which are not easily explained by classical evolution theories. These events are marked by rapid diversification and the emergence of entirely new species, leaving scientists puzzled about the underlying mechanisms. The Cambrian explosion, often referred to as life's Big Bang, saw the sudden appearance of most major animal phyla within a geologically short period, around 541 million years ago. This event is characterized by the rapid diversification of life forms, with complex organisms appearing seemingly out of nowhere, challenging the gradualistic views of evolution. The Cambrian flashpoint is considered an era of innovation, where life forms diversified rapidly, leading to the emergence of complex organisms in a geologically brief period. Unique conditions, such as geological anomalies and geochemical shifts, are believed to have ignited this explosion of life, presenting a mystery for classical evolutionary theories. During the Cambrian explosion, geological anomalies, such as massive tectonic shifts and volcanic activity, created an environment ripe for biological innovation. These anomalies contributed to the unprecedented diversification of life forms, with new species emerging at a rate that defies the gradual timelines of traditional evolutionary models. The Cambrian period saw radical shifts in Earth's geochemistry, including changes in ocean chemistry and climate, which may have triggered one of evolution's most dramatic events. These unexplained shifts are thought to have created conditions that allowed for the rapid emergence of complex life forms, marking a significant turning point in evolutionary history. The Cambrian novelty refers to the abrupt emergence of entirely new body architectures and sensory systems, which remain a puzzle for classical evolutionary mechanisms. This period saw the rise of complex organisms with novel features, such as exoskeletons and advanced sensory organs, challenging the traditional understanding of evolutionary processes. During the Cambrian, novel body plans emerged seemingly out of nowhere, with organisms developing unique structures like exoskeletons and segmented bodies. Classical evolutionary theory struggles to account for the rapid innovation and complexity of these new forms, which appeared in a geologically short time frame. The Cambrian eye enigma highlights the sudden evolution of complex vision systems, such as the compound eyes of trilobites, which appeared almost instantaneously in the fossil record. This sensory revolution suggests a rapid evolutionary pace, raising questions about the mechanisms that could drive such swift developments. The Cambrian triggers remain a mystery, with debates over whether environmental forces or genetic revolutions fueled this biological Big Bang. Unseen factors, possibly involving genetic innovations like the Hox gene, are thought to have played a role, yet they continue to puzzle scientists and challenge classical theories. The oxygen's paradox suggests that a sudden surge in atmospheric oxygen levels might have been a key factor in the Cambrian explosion, yet this explanation may be too simplistic. While increased oxygen could support more complex life forms, the timing and scale of the Cambrian's complexity suggest that other factors were also at play. The Hox gene revolution is often credited with orchestrating the Cambrian complexity, yet some scientists speculate that other genetic mechanisms might have played a role, challenging the gradual mutation models. These genes, responsible for the body plan development in animals, appear to have undergone rapid changes, suggesting a genetic leap that classical theories struggle to fully explain. Exotic theories propose that cosmic events, such as asteroid impacts or supernovae, might have contributed to the Cambrian leap, hinting at missing pieces in our understanding. These events could have triggered environmental changes or genetic mutations, providing a catalyst for the sudden diversification of life forms. The sudden appearance of insect wings, a triumph of evolution, raises questions about their origins, as they seem to have emerged without the gradual development expected by classical models. This evolutionary leap allowed insects to dominate ecosystems, showcasing a remarkable adaptation that remains a mystery to scientists. The fossil record reveals that delicate insect wings appeared almost overnight, presenting a winged wonder that challenges the idea of gradual development. These wings, preserved in ancient amber, suggest a sudden innovation that defies the slow pace of classical evolutionary change. Around 320 million years ago, the sudden fossil appearance of wings marks a flight revolution, contradicting the gradual accumulation of traits expected by classical theory. This rapid emergence of flight capabilities in insects suggests a unique evolutionary event that remains unexplained. The transformation from gill to wing is a puzzling transition, as classical gradualism struggles to explain how existing structures evolved into complex wings. This obscured origin hints at a missing link in our understanding of evolutionary processes. The impact of flight on ecosystems was profound, triggering an ecological upheaval that led to the diversification of insects at a pace difficult for classical theory to reconcile. This revolutionary adaptation allowed insects to exploit new niches, reshaping the ecological landscape. The immediate survival advantage of flight provided insects with an escape velocity, driving the rapid evolution of wings seemingly too fast for gradual selection. This advantage enabled insects to evade predators and explore new environments, accelerating their evolutionary success. Flight facilitated the global domination of insects, allowing them to disperse and diversify on a scale that outpaced the expectations of classical models. This unstoppable spread of winged insects highlights their adaptability and resilience, reshaping ecosystems worldwide. The genetic leaps that enabled wing development remain an unexplained innovation, challenging the gradual mutation framework of classical evolution. These flight genes may have undergone rapid changes, suggesting a unique evolutionary pathway that defies traditional explanations. The genetic blueprint for insect wings reveals unexpected complexities, with certain wing genes showing signs of abrupt changes rather than the gradual evolution typically anticipated. These genetic shifts suggest a less understood mechanism that might have accelerated the development of flight capabilities in insects. Environmental factors, such as climate shifts and habitat changes, may have acted as catalysts in the rapid evolution of insect wings, suggesting a role beyond genetic mutations alone. This environmental influence could have sculpted wing structures in ways that classical gene-centric views struggle to fully explain. Unconventional theories propose that wing origins might involve external influences or unknown processes, challenging the limitations of classical evolutionary explanations. These alternative ideas suggest that the development of wings could have been driven by factors not yet fully understood by mainstream science. The sudden emergence of flowering plants, often referred to as Darwin's abominable mystery, continues to baffle scientists due to its unexpected timing and rapid diversification. This floral explosion occurred in a geologically brief period, leaving a puzzling gap in the evolutionary timeline. Flowering plants appeared abruptly around 130 million years ago, marking a sudden genesis that challenges the notion of gradual plant evolution. This floral genesis remains a mystery, as the fossil record shows a lack of transitional forms leading to their rapid rise. During the Cretaceous period, flowering plants experienced a geologically rapid rise, transforming the landscape with their diverse forms. This revolution in green challenges the classical view of slow plant evolution, as flowers quickly dominated ecosystems. The evolutionary origins of flowering plants remain elusive, with missing ancestors hinting at gaps in our understanding of their lineage. This unclear ancestry suggests that key evolutionary steps may have occurred in unrecorded environments or through unknown processes. The astonishing speed at which flowers reshaped ecosystems presents a puzzle for the concept of gradual ecological change. This floral power transformed habitats and interactions among species, leading to a dynamic shift in the natural world. Flowering plants achieved global dominance with remarkable speed, seemingly outpacing the expected gradual ecological succession. This floral takeover allowed them to thrive in diverse environments, showcasing their adaptability and resilience. The coevolutionary burst between flowers and their pollinators may have driven floral diversification at a pace unpredicted by classical models. This pollination puzzle highlights the complex interactions that could have accelerated the evolution of both plants and their pollinating partners. Charles Darwin referred to the sudden appearance of flowering plants as an abominable mystery, questioning how such complex organisms could emerge so rapidly without clear ancestral links. Despite advances in genetic research, this evolutionary enigma remains unresolved, leaving scientists to ponder whether classical theories can fully explain the floral explosion. Darwin's description of flowers as an abominable mystery continues to resonate, as the fossil record lacks the transitional forms expected by classical evolution. This persistent gap suggests that our understanding of floral origins may still be incomplete, highlighting the limits of current scientific explanations. The concept of genetic fireworks suggests that genetic innovations might explain the rapid diversification of flowering plants. Yet unexplained factors could also be at play. While genomic studies reveal complex genetic changes, the speed and scale of floral evolution hint at additional influences beyond known mechanisms. Despite significant research, the frontier of floral evolution remains filled with unsolved questions that challenge classical theories. These mysteries include the origins of key traits and the mechanisms driving the rapid adaptation of flowers, suggesting that our understanding of plant evolution is still evolving. Mass extinctions, such as the Permian-Triassic event, reveal evolutionary mechanisms that might extend beyond classical gradualism, acting as catalysts for new life forms. These catastrophic events often lead to creative bursts of evolution, reshaping the biological landscape in ways that are both destructive and innovative. A mass extinction is defined by the loss of a significant percentage of Earth species in a relatively short period, exposing the limitations of classical evolutionary predictability. These global events often result in dramatic shifts in biodiversity, challenging our understanding of evolutionary resilience. Mass extinctions differ from normal extinction rates by causing the widespread disappearance of species, acting as evolutionary game changers. These events create opportunities for new species to emerge, leading to rapid evolutionary changes that redefine ecological dynamics. The global fallout from mass extinctions triggers planet-wide ecological and atmospheric chaos, surpassing typical evolutionary pressures. These cataclysmic shifts can lead to drastic changes in climate and habitat conditions, forcing species to adapt quickly or face extinction. The Big Five mass extinctions, including the Cretaceous-Paleogene event, resulted in unprecedented losses and reshaped life in ways that classical theory struggles to explain. These events led to the emergence of new species and ecosystems, highlighting the transformative power of catastrophic change. The Permian apocalypse was a near-death experience for life on Earth, with over 90% of species wiped out, leading to unexpected evolutionary paths for survivors. This catastrophic event forced species to adapt in novel ways, resulting in evolutionary developments not fully predicted by classical models. The dinosaur demise around 66 million years ago opened the door for mammalian dominance, as these small, adaptable creatures quickly filled the ecological niches left vacant. This rapid transition is marked by the emergence of diverse mammalian forms, showcasing a swift adaptation that classical gradualism alone might not fully explain. The concept of creative chaos suggests that mass extinctions can paradoxically act as catalysts for evolutionary leaps, where the destruction of dominant species paves the way for new life forms to emerge. This idea of creative destruction highlights how catastrophic events can lead to unexpected opportunities for biological innovation beyond classical adaptation. Mass extinctions create niche vacancies, offering a fresh start for surviving species to rapidly diversify and fill the ecological voids left behind. This process challenges the classical equilibrium models by demonstrating how sudden environmental changes can lead to swift evolutionary adaptations. The phenomenon of adaptive explosions following extinctions illustrates how new forms can arise from the ruins of past life, showcasing evolutionary bursts that classical theory might struggle to fully encompass. These rapid radiations highlight the dynamic nature of evolution, where species diversification occurs at an accelerated pace. The triggers of mass extinctions often point to factors beyond classical evolutionary drivers, such as asteroid impacts or unknown Earth system dynamics. These catastrophic events reveal the complex interplay of extraterrestrial influences and planetary changes that can lead to dramatic shifts in biodiversity. The theory of punctuated equilibrium proposes that evolutionary leaps occur in short, rapid bursts, challenging the classical gradualism model. This concept suggests that long periods of stasis are interrupted by sudden changes, offering a refined explanation for the jumps in evolution. The debate between punctuated equilibrium and classical gradualism represents a theoretical divide in understanding evolutionary change. Punctuated equilibrium posits that rapid evolutionary shifts better explain the sudden appearance of new species, contrasting with the slow, continuous change proposed by gradualism. The core principles of punctuated equilibrium emphasize stasis and spurts, where long periods of little change are followed by brief, intense evolutionary activity. This contrasts with classical gradualism's assumptions of steady, incremental change, highlighting a fundamental difference in how evolutionary processes are perceived. The concept of continuity versus discontinuity in evolution questions whether evolution proceeds smoothly or in fits and starts, as suggested by punctuated equilibrium. This debate has significant implications for classical theory, as it challenges the notion of constant, gradual change in favor of episodic bursts. The mechanisms of punctuation in evolution explore what drives these rapid evolutionary jumps, potentially exposing gaps in classical explanations. Factors such as environmental catastrophes or the emergence of hopeful monsters may act as leap triggers, leading to sudden, significant changes in species development. Environmental shocks, such as volcanic eruptions or asteroid impacts, may act as catalysts for evolutionary leaps, creating sudden changes that force species to rapidly adapt. These abrupt crises can lead to new evolutionary pathways, suggesting that catastrophes might play a more significant role in evolution than previously thought. The concept of hopeful monsters suggests that major genetic mutations could lead to significant evolutionary changes, producing organisms with new traits that might thrive in changing environments. These genetic jumps challenge the focus on small, incremental changes, proposing that large mutations could be a driving force in evolution. Fossils and genetic studies provide evidence for punctuated equilibrium, showing periods of rapid change followed by stability. While the fossil record reveals sudden appearances of species, genetic data highlights rapid shifts, leaving a mystery about the mechanisms behind these evolutionary jumps. The fossil record often shows abrupt appearances of species, suggesting jumps rather than gradual transitions, which supports punctuated equilibrium. These gaps in the record imply that evolutionary changes may occur in short bursts, challenging the classical model of slow, continuous evolution. Genetic studies reveal periods of rapid evolutionary change, supporting the idea of punctuated equilibrium over classical gradualism. These genetic clues suggest that evolutionary shifts can happen quickly, with significant changes occurring in a relatively short time. Punctuated equilibrium has reshaped our understanding of evolution by highlighting the limits of classical theory's explanatory power. This concept suggests that evolutionary change may occur in rapid bursts, prompting a rethink of how species evolve over time. Punctuated equilibrium has fundamentally altered our view of evolution, suggesting that the classical theory may be incomplete. By proposing that evolutionary change occurs in sudden bursts, it challenges the idea of steady, gradual evolution. Punctuated equilibrium offers new insights for conservation, emphasizing the potential for rapid adaptation and highlighting the limits of classical predictions. This perspective suggests that species may be able to quickly adapt to environmental changes, providing a fresh approach to conservation strategies.